Okay, so I'm going to move over into the actual flow analysis tool itself, which is basically, it starts off with picking what sort of station you want to look at. So there's a number of different ways that you can search. Just like Google Maps, you can zoom to location. So I'm going to zoom into Fort Collins just because most of us are familiar with that area a little bit. You can search by just keyword, like if I wanted to examine just flow analysis gauging sites on the Poudre River, what it's going to do is it's going to search the entire combined database of USGS monitoring sites, STORET monitoring sites, CDWR monitoring sites, and then it'll put them all on this map. You can see that it's pretty much just concentrated to where the Poudre River is in Colorado. And the different colored pins are the different databases. So the red ones here are STORET monitoring sites, the green ones are CDWR, and the blue ones are USGS. When you find a site that you're interested in, you can click on it and you'll get this nice little summary of who it is, where they're at, where's it actually at on the river, and a little data summary of what sort of data was available a couple years back when we did a full summary of these different databases. But the cool part of the flow analysis tool is actually right here in the flow analysis model part, is the actual heart and soul of the tool itself is the analyses. So again, it starts off with that nice little summary of all the different station attributes in that data summary, but you can actually start digging into analyzing the data that's available for this site. One thing that we've added on top of this, I see that we got a quick question. So one thing that we've added on top of this is if you want to analyze not only USGS data, you can analyze uploaded data. You can analyze only your uploaded data or merge it in with the available USGS data. And you get to that link here on the Station tab under this Upload Your Own Data. And this first little section here describes how you need to format it. The basic format is a CSV file with a date and a value. And then a header that says date and then what kind of water quality test it is. So if it's a flow test, you got to signify it with flow. If it's one of the USGS nutrient tests, you got to signify it with this 5-digit code that USGS uses. So 00600 is their total nitrogen code. That'd be how you'd upload your CSV file to use it in this particular tool. And it's a straight once you got that file formatted, you just pick it out on your computer and upload it. Did I clarify that okay? Cool. Thank you. But all of the analyses are set up to analyze just uploaded data or analyze the merge or just the USGS data itself. On this data tab, the data tab is more of just like a statistical summary of what's available for a given site. It has a whole bunch of different advanced options that you can go in and specify seasonal statistics for a summary CSV file you can get. You can get some extra different inputs for graphing options. You can do period analysis. So say you're examining a stream gauge that had a dam put in upstream of it. You could examine the record before the dam and after the dam and during construction as 3 different periods and see what sort of statistical differences there are. Once you run the analysis, you're going to get a series of summary graphs and summary statistics. Everyone knows what the standard time series looks like. And you got a little statistic summary here on the average flow of this particular site is 157 CFS. You got a nice little envelope plot that plots all the different years on top of each other so that you can see the average. That's this black line. That's the average flow over the entire period of record versus the median versus every single year plotted as a gray line and last year or this year as that light blue line. You can also do pixel-based plots, which are some of the more advanced forms of analyzing time series data. We also have just monthly averages, histogram plots, and CDF curves. And like I said, one of the things that you can get out of this one is a summary CSV file that includes all sorts of statistics about this flow analysis tool. So for a given period of record, for the entire period of record, you can get how many data points there are, the maximum, the minimum, the 1-day maximum average, the 3-day maximum average, the 7-day minimum, all sorts of stuff. This is all based on Nature Conservancy indicators of hydrologic alteration. So there's tons and tons of different statistics in this file. And then not only does it summarize it for the entire period of record, it summarizes it per year as well. So you can compare 1979's data versus 2015's data all the way over here if you wanted to. But we don't need to go that deep into it. One of the options that all of these tools have is you have those static graphs. You can also choose to use a more dynamic graph, and this allows a little more web interaction that you can actually start playing with the data and seeing a little bit better. With some of those, with those big pixel plots, with those time series, you can actually zoom into a smaller scale resolution on the dynamic graph and save it or upload it or download it or view it. It does take a little bit longer to load those graphs just because they're all that data is getting pulled into the web browser itself, so there's a loading slowdown there. As far as the biological flow stats, those are not currently included in that CSV file. Those biological flow stat summaries are available in a low flow analysis that is inside of the CDPHE tools. And I can show you that if time permits. But like I was saying, with these dynamic graphs, you can actually just hover over the points and zoom into a given area of interest if you want to look at, say, this flood peak on November 15th in 1984. So that's those dynamic graphs I was referring to, and all of them are dynamic, so you can go through and view them a little bit differently. There's also a flood analysis method in here that is based on the USGS Bulletin 17B flood Skewness method, which fits a logarithmic distribution of flow data, and then it plots not only the observed data but the interpolated data as well as confidence intervals around that for flooding, peak flow values out of the USGS, and then gives you a summary of recurrence intervals. So you can say, what is the 200-year flow here? Well, the 200-year flow here, according to the Bulletin 17B method, is a 14,000 CFS flow, plus or minus those confidence intervals, of course. The flow analysis tool also includes a drought analysis, which is a statistical regression of annual flow data and annualized total acre feet per year flow data relative to the average over time, or some sort of drought threshold that you specify in acre feet. And you can determine when you've had those periods of low flow. And then it fits a regressive model to it, forecasts it forward, and then comes up with this nice summary graph of the length of the drought versus the lambda, which is the color coding on this, is the magnitude of the drought versus the recurrence interval of the drought. The colors are, of course, the forecasted data, and the black line is the historic data. So, you know, so for this particular one, I didn't pick a very good regression model because those lines don't exactly overlap. But you can go back to the interface and fine-tune the magnitude of that regression, the type of regression, or you can optimize it here. And that's the drought analysis. And it has that similar if you want to look into the interactive graphs versus just the static ones. One of the other features we have in the flow analysis tool is this base flow analysis, which basically does a filter regression to pull out base flow relative to stormwater stream flow, and highlight the difference between those two, as well as some statistics. This is all based on a tool by Arnold and Allen with the USDA out of Texas, A&M University. So it's got some statistic summaries about different base flow fractions depending on which filter paths you're using. And you can download those result data as well. One of the cool ones is the flow duration curve and the load duration curve analysis, which you can take a flow duration curve, which is basically a time series of flow data rearranged by magnitude and how frequently it happens. You can take that and multiply that against a water quality standard that you're interested in. Say I want to look at a 2 milligram per liter water quality standard at this site. This will combine the observed nutrient data for total nitrogen versus the flow data and the combination of the two, and it's going to spit out a summary graph of total acceptable load relative to flow magnitude and how frequently that happens, as well as where observed data lies on that entire plot, which is really helpful in going down the road towards the TMD analysis. Sorry, TMDL, my bad. And once that loads real quick, any questions so far on the flow analysis tool? So what it does is it'll summarize those flows. These are the flows times the water quality target concentration that you set for a grand total of kilogram per day total nitrogen load in this river. And you can see for the given year, you've got that standard red line, and then you've got the total records, the red line, and then each individual year is plotted as the gray line, so you can start seeing some of the natural variability in these stream flow systems.
What's the red line again?
The red line is the total average for the entire flow record.
Okay.
And each individual gray line is a single year. And that's all explained up in some of these summary paragraphs under this further model info. So if you have any questions about any of these particular tools, you can hop in and read up on the flow duration curves, what they're doing, the load duration curves, what the seasonal is, how it tries to detect different pollutant sources based on where the observed data is greater than the desired curve, and other things like that, and then different management practices that are probably likely to help this. In this particular case, all this data on the load duration curves was developed based on recommendation guidelines from Bruce Cleland with the US EPA under his TMDL management approach. But all of the tools have this further model info button so that you can go in and see what's actually going on behind the scenes and what these tools actually are. But the red line is the total data, and the gray line is each individual year, and then the green dots are all the different all the different nutrient concentration observations. So for a given observation, you can tell that these are certainly higher than that 2 milligram per liter standard that we set. And then the little black dots overlaid on top of that is a seasonal look at it. So under this advanced option, you can specify, do I want to look at the winter season? Do I want to look at the spring season? Is this a snowmelt dominated river? Is this more like a hurricane, tropical cyclone kind of dominated river, or is it some sort of other trend? And you can look at the seasonal differences in those water quality points. And like I said, for any of these tabs, if you had any question on what the model is actually doing, you can just click that model info guide, and it's going to run you through exactly what's going on behind the scenes as far as those regression equations and how it fits everything, and then all the documentation on where this work came from. Same with the flood analysis tool. You can hop in there and you can see all the notes on the different Bolton 17B methods, as well as the original guiding document that the USGS came out with, some of their frequently asked questions, and then one of the bigger things used in flood regression is the standardized flood skewness coefficient, which is complicated if you get into it, but we've pre-processed that all for you guys, which helps. And one of the last tools that we have floating around in here is the LoadEst tool, which is a load estimator tool, which takes observed flow data, observed water quality data, and then interpolates between there so that you have a bigger record of water quality data. It's of course based on fitting a model to that data, but this was produced by the USGS, so they're pretty happy with the quality of that model. So you can sit down and look at water quality loads over time as far as kilograms per day for a given period of time, and then some statistics about it as well. You can also look at, say, the monthly averages of those loads over time versus the annual loads over time. Any other questions on the flow analysis tool at the moment? I guess the only other real thing that I'd like to highlight is one thing that I frequently use this tool for is I find this interface pretty straightforward to find a gauging station of interest, and you can also just hop over to a tab and say, I want to download flow data, It'll download the actual USGS flow data, or if I only want the flood data, or if I want the nutrient data for that total nitrogen, it'll download that for me. Just based on what tab you're on, it'll download the right data for you. It'll also, there's also a link here that sends you out to the USGS data site itself for a summary of what that site is. So you can see their version of all the data and how that interface to act with extraction and that sort of stuff. And that's just the site info link. And if you're on a store it station, it'll take you to store it summary. If you're on a CDWR station, it'll take you to CDWR station.